ladies and gentlemen.
Let's talk systems of linear equations. So what we typically look for in a system of linear equations is we try to look for an intersection point. So we try to figure out what value of x and y typically make both equations true at the same time. Graphically, that would look like an intersection point. Sometimes you may be asked weirder questions, especially on a standardized test or a college entrance exam or something like that, where you're not necessarily looking for an intersection, you're taking two equations and you're doing something weird with it. That happens in question 1. So question 1 here says, if we have 2x plus y is equal to 7, and x minus 5y is equal to 10, what's the value of 3x minus 4y? Well, first and foremost, can I take any of my equations and easily manipulate them to make this? Well, 3 is 1.5 times 2, but negative 4 is not 1.5 times y. I can multiply this x by 3 and multiply this by 3, but that wouldn't make the y's the same. So it doesn't look like it, right? But let's look at the actual, variables that we have in both equations. I have a 2x and a 1x, and I want it to be 3. And I have a y and a negative 5y, and I want it to be negative 4. What if I take my equations, the 2x plus y, which equals 7, and this x minus 5y, which equals 10, and I add those together? What if I add the left sides together and the right sides together? What happens? So let's add these together and see what happens. 2x plus x is 3x's. 1y plus negative 5y is negative 4y. And 7 plus 10 is 17. Now I have an expression is equal to the expression I want it to be, which is equivalent to 17. So that is the value. That is called, typically that process of adding equations together is used in elimination, which there's two major ways to solve linear equations besides graphing. There's substitution and elimination. I favor the substitution, but elimination is also useful. And knowing both is even more useful because there are times where you use one and times you use the other. This one, adding the two equations together, that's really the only way you could go about solving that equation or that problem. The next one, word problems. Liz needs to determine the difference in weights of several stuffed animals. The problem she encounters is that the scale she needs to use will not register the weight of individual toys. She decides to weigh the bear and the frog together, and the combined weight is 137. So the bear and the frog weigh together 137. The combined weight of the bear and the turtle is, so the bear and the turtle is 216, and the turtle so now we need to figure out how much the turtle weighs in comparison to the frog. So if I take the turtle's weight and I subtract the frog's weight from it, how much is that? So what we're looking for is t minus f is equal to question mark. How can I take these equations and figure that out? Well, if I subtract them as is, I would be doing b minus b, which would be nothing, f minus t, which isn't t minus f. So what if we flipped these equations? What if I take the top one and I flip it to the bottom? Now what happens if I subtract them? If I subtract them now, the b's still cancel. That goes to 0, which we don't care about. And then t minus f, we get t minus f. But if we subtract these sides, well, that's a little interesting to work with. Let's actually make this side easier to work with. 216, 137, not nice numbers. But if I subtract 16 from both, they'll get a little bit nicer. I'll have 200, and then 137 minus 16 would be 121, and those are a lot nicer to subtract. 1, because I can borrow very nicely, and then 9 minus 1 is 8, 9 minus 2 is 7, and then 1 minus 1 is 0, so we get 78. So T minus F, how much more does the turtle weigh than the frog? 78 ounces. That's not ounces. 78 ounces. Not too bad. You can use some tricks to make some math a little bit nicer for you. The next one, a teacher purchased 22 tickets total for a field trip to a concert. There were student tickets priced at $12, so $12 per student ticket, and patron tickets priced at $18, plus $18 for the patron tickets. The teacher spent $348 total. So price per student, price per patron equals $348 total. And there were 22 tickets sold total. So between students and patrons, there were 22 people total. We need to solve this system to figure out how many of which person went. Oh, we don't actually need to. We just need to write the equations. I jumped the gun. So these are our two equations for this situation. Not too bad. Let's solve a system. So two major ways to solve, and I'm going to show you both ways to solve here. One is you have a system like this where you have variables, and we can easily see that if I add the two systems together, they cancel out nicely. I would add the two systems of equations together. Let's add these and figure out what happens. X plus x is 2x. Positive y plus negative y is 0. So that kind of goes away. And then 3 plus 5 is 8. So 2x is equal to 8, which means x is equal to 4 when you divide by 2, right? Now I can use this and substitute it into any of the equations to figure out what the y is. So x plus y is equal to 3, right? Well, x is 4, so 4 plus y is equal to 3, or y is equal to negative 1. Not too bad, right? So our solution to this system would be x equals 4, y equals negative 1, or you could write it as a point 4 comma negative 1. Not too bad, right? Let's do this one, and we can do this one through substitution. If you look, the bottom equation is only one variable. We have a y. So you have a minus 2, a minus 4. Let's add 2 to both sides. We get y is equal to negative 2, and we can use this value of y to figure out x in the system. So we have x plus 2y, which is negative 2, is equal to 7. 2 times negative 2 is negative 4, so x minus 4 is equal to 7, or x is equal to 11. This one, it didn't ask for both the x and the y, it just asked for what the x value was in the system. If it asked for the y, this would have been all we needed to do. Our last equation together, a little bit different. What's the solution to this system? Well, if I look, I could solve this through substitution, same way I kind of did up here. I can solve it for a variable and plug that in. But if I look here, there's a structure here. 5x plus y is 12. 10x plus 2y is 24. I notice that 5 doubles is 10, and y double is 2y. 12 doubles 24. So if I just multiply this entire equation by 2, I get 10x plus 2y is equal to 12. Or not equal to 12, is equal to 24. And then I have 10x plus 2y is equal to 24 from the last equation. So this is the top equation, and then this is the bottom equation. They're exactly the same. What does that mean for our solutions? There are infinite solutions, and that is because they are the exact same line. If the line falls right on top of the other, then they share all of their points together, so they have infinitely many solutions. So Typically, when you solve these systems, you either have one solution if they intersect, no solutions if they're parallel, or infinitely many solutions if the two lines fall one right on top of the other. So just keep that in mind. But you can solve them, again, through substitution or elimination, where you solve for one variable, plug that into the other equation, and then solve for the variable that's left. Or you can add and subtract the equations together, and you can multiply the equations first if need be to add and subtract together to cancel out one of the variables, solve for the other, and plug it back in. Either or will get you the right answer. Good luck with your practice, and if you have any questions, let me know. I'll see you in the next video.